Okay, now we jump into perfect squares. And so this is another type of special factoring. And so we want to recognize when it's a perfect square. And that way, then we can do it a faster way than what we would do using the box method or using grouping or doing something else to be able to factor it down. So here is a perfect square. Now you've seen these before. We didn't really talk about them being perfect squares, but at least not this terminology. So we have x plus y quantity squared or x minus y quantity squared. When I multiply these two out, I get, remember that we have to do x plus y times x plus y. So if I do that and I FOIL it, I get x times x, which is x squared, x times y, which is xy, another y times x, so another xy, can be written either way, and then y squared. So you see my y squared. So I really have two xy's in there, so it would actually multiply out to being this. So if it's in this form, then we can go backwards over to that form. So we're going to take a look at a couple of problems. So first one is going to be this one right here, and then we're going to go into some other problems. And so in this particular example, notice I just multiplied some things out. So this is supposed to be in parentheses there. And notice I have 9x squared plus 2 times 3x times 2. So here's my 2 from there. There's my x value in a sense, and there's my y value. So notice, of course, this is 3x times 3x. This is 2 times 2. So if you'll notice, this 2 goes here, and this 3x goes here, and then we have our 2, which is kind of right in front. But I want you to kind of see something as we do that. So this becomes 9x squared. 2 times 3 times 2 is 6 times 2, which is 12x, and then plus 4. So I'm just rewriting this. I'm not doing anything else yet. Okay? Now, if it's in this form right here, if it looks like this, and it's exactly what that is, this is going to factor directly out to 3x plus 2 times 3x plus 2, which is really 3x plus 2 squared. So anytime we have a perfect square, both of the signs have to be the same. Now, the sign in here always follows whatever the sign is in here. So notice this is a plus, so therefore these are both pluses, and this is a plus. Notice here, because this sign in the middle is minus sign, then this sign would be a minus. So let's see if we can figure out this one. I'm going to write it above. Notice that this is 4y times 4y. This is 5x times 5x. So notice the 5x is here, the 4y is here, and then we have our 2, which is right there. So notice that we have this form. This is really just 16y squared minus 2 times 4 times 5. 4 times 5 is 20 times 2, which is 40. So that would be 40y, and then plus 25x squared. So now we know that we have it in the right form. So which means, how does it factor? It would be 4y and 4y. It would be 5x and 5x. Those are coming from these numbers here, or these values here. And then we have a minus sign, so both of them have to be negative. So then my answer would be this, which of course would be 4y minus 5x quantity squared. So either written this way, or I could square it and write it similar to this one right over here. But you can see how that middle term really kind of works out there. Okay, let's do some problems. 16x squared minus 56x plus 49. Now, you can see that this is a perfect square, meaning it's 4x times 4x. This is a perfect square, 7 times 7. So that means it's potentially a perfect square, but we have to prove that. So we have to prove first that this middle term is 2 times 4x times 7. So we're going to multiply the 4x times the 7, and then we're going to multiply everything by 2. So 2 times 4 is 8. 8 times 7 is 56. So this works out to be 56. We have an x in there, 56x, which is correct. So therefore, it is a perfect square. If it's a perfect square, it just factors down to 4x minus 7, and 4x minus 7. You have to remember that they're both negatives. For perfect squares, they're both the same sign. For difference of squares, they're different signs. And so that is equal to 4x minus 7 quantity squared. Okay, m squared. So this is really m times m. This is 3 times 3. It looks pretty good so far. Then we have to multiply the m times 3. So m times 3 times 2, right? Because we have the 2 to see if it's the middle term. And so 3 times 2 is 6, so that is 6m. Notice it is a 6m. I don't really care about the negative or the positive because that just tells me what the sign is when we're done. So that gives me m minus 3, that's where the sign comes in, times m minus 3, which is equal to m minus 3 quantities squared. Okay, next one. And the last one, this one is 3z times 3z. This is 1 times 1. Might be a perfect square. We don't know yet. We have to multiply those two and then multiply it by 2. So it's 2 times 3z times 1, which is 6z. Therefore, it is a perfect square. So that means it factors down to 3z minus 1 times 3z plus 1. Okay, which is the same thing as 3z plus, whoops, can't believe I did that. I made the mistake that I tell you guys not to make. Both of them are minus. So it's minus 1 quantity squared. And there we go. That's it. We're done with this section.